This is an intro to volume of revolution with washers. In the previous video, I went over finding the volume of revolution using the disk method, or disks, and in this video I'll go over finding the volume using the washer method. The methods are pretty similar, but the hardest part is identifying when to use the disk or the washer. So in terms of the question types, it will come in more or less the same form. It will ask you to find the volume of a solid obtained by rotating a region bounded by an equation with some other bounds about the x-axis or y-axis. So the first step when looking at a volume of revolution question is to draw a graph. And after you draw a graph, you should input all of the equations given to you. So in this case, y equals x squared is given to us. So I'm going to input y equals x squared and y equals 4, which is 1, 2, 3, 4, this horizontal line. And since there are no more equations given to us, we can move on. We're rotating this area around the x-axis, which is this axis here. And so when we rotate this area, we get something like this. And so we get a 3D figure. And so it has depth. So it's a 3D figure. And once I had drawn the graph and identified what solid is obtained by rotating the equation, we can now figure out when to use the washer or the disk method. So an easy way to figure out when to use the washer method is to look at the solid and decide if it's hollow or not. And so what I mean by hollow is when you look at the 3D object, does it look like it's caving in, or that you can pour a liquid inside? If you can pour a liquid inside the solid, that's a good indication that it's going to be a hollow 3D figure. So in this case, it's obvious that if we pour a liquid inside, it will stay there. And so since we have this hourglass type of shape, we know that we need to use the washer method here. And so the washer method is similar to the disk method in that we use the same formula, the formula for the volume of a cylinder. So that is pi r square h. And then we convert that into an integral. So we write the integral of pi r square h. And that is in the case of the disk method. But in case of the washer method, we have actually two radiuses. R is radius. And to differentiate between the two radiuses, we have the uppercase r and a lowercase r. The uppercase r is for the outer radius. So that's usually this radius, which is constant. And the inner radius, r, lowercase r, is the inner radius. And that usually varies. And so it's usually an equation. In this case, the equation given to us is x squared, y equals x squared. And so all you need to remember is that the uppercase r is usually a constant and the lowercase r is an equation. So in this case, the constant given to us is y equals 4. And that is the outer radius. So if you look at the 3D figure and look at the radius, you can see that the outer radius would be this longest part, this part here. And so that part is actually, if you look at the graph, it's 4 units tall. So we know that the outer radius is 4, which is a constant. And the lowercase r would be the varying equation. So in this case, it would be x squared. So once you've identified the graph, the solid, and the uppercase r and lowercase r, we can input all of that into our equation, which is pi uppercase r square minus pi lowercase r square. Then this is in brackets dx. So what I did basically is I'm subtracting the outer cylinder by the inner cylinder. And what I mean by this is if you take pi r square and there is an h, the height is dx, and dx is multiplied by both terms. So pi r square h, this is the formula for the volume of a cylinder. But what cylinder? The cylinder I'm talking about here is this outer or bigger cylinder, this larger cylinder. And so this cylinder has depth. And so when we take the volume of this large cylinder and we subtract it by the volume of this small cylinder, this space here, we get this solid which we're trying to obtain, the volume of this solid. And so this is what we're trying to obtain. And so when we subtract the larger cylinder by the smaller cylinder, which is this part, we get this blue part, which is what we're finding. And so after we got this equation, we need to figure out the bounds, from which lower bound to which upper bound. And so to figure that out, we need to look at what axis is the area revolved around. So in this case, it's rotated around the x-axis. And so since you know it's the x-axis, we just need to figure out where the equations intersect on the x-axis. So in this case, to figure out where the line y equals 4 and y equals x squared intersect, we need to set it equal to each other. So if we set x squared equal to 4, we get x is equal to plus or minus 2. And so that makes sense. It'd actually be somewhat like this, the equation. And so it intersects here. And so that's where it starts. And this is where it ends. So -2 is our lower bound, and 2 is our upper bound. So to figure out the bounds, all you need to do usually is to set the equation equal to each other. The equations, or the equation and the constant, equal to each other. And find the value of x, or if it's revolved around the y-axis, you're finding for y. So in this case it's x, and we can now just plug in everything we know. So large R we talked about was 4. And before we do that, actually, we can take the constants out. So in this case, pi is a constant, so we can take that out. And we get r squared, which is 16, because 4 squared is 16, minus small r squared, which is x squared. X squared to the power of 2 is x to the power of 4. And this dx. And so from here, all we need to do is integrate. And we can do this by using the power rule on each term. We would get 16x minus x to the power of 5 over 5 evaluated from -2 to 2. And don't forget the pi. So we're multiplying everything by pi. And so now all we need to do is plug everything in. And so when you plug in 2, 16 times 2 is 32. I'll write it here, 32, minus 2 to the power of 5, which is 32, over 5. And so this is equal to it would be 128 over 5, right? And so 128 over 5 minus the lower bound, so you need to plug in -2 now. So 16 times -2, which is -32, minus 2 to the power of 5, -2 to the power of 5, which is negative 32. And so this becomes plus 32 over 5. And so when we get that, we get negative 128 over 5. And so when we subtract 128 over 5 minus 120 over 5, we get 128 over 5 plus 128 over 5. So in that case, it would be 256 over 5. So our answer is not 256 over 5, it's 256 pi over 5. So this is our area, or this is our volume of this solid. And so the basic steps are writing down the graph, inputting the equations, making the 3D figure, identifying whether it's hollow or not, and then if it's a washer, find the uppercase R or the outer radius, and then find the lowercase r or the inner radius, and then use this formula. Pi r square, pi uppercase r square minus pi lowercase r square dx. And to find the bounds, you set the equation equal to each other. We're asked to find the volume of the solid obtained by rotating the region bounded by y equals x squared and y equals x plus 2 about the x-axis. So in this case, we have y equals x squared and y equals x plus 2 as our two equations. And so the first step, drawing the graph. And so when we draw the graph for this is x plus 2, x squared, this is x squared, and x plus 2 would look something like this. And so the area between these two equations is this. And so that's the area between these two equations. And we're asked to rotate that about the x-axis, so this way. And when we rotate that, we get something along the lines of this. And it's a 3D shape, so keep in mind, this is a 3D shape. And so if you rotate that this way and we get a 3D shape. Now looking at this figure, it's a little bit hard to tell, but looking at this figure, can you tell if it's hollow or not? And so looking at this, if you look carefully, you'll be able to tell that if you pour a liquid inside this shape, it would stay there. And so actually this part is actually covered as well, because if you cover this, it would end up looking like a bowl, sort of a bowl with a hollow bottom. And so anyway, we can tell that it has a hollow shape. And so since it has a hollow shape, that means we need to use the washer method. And so the first step of trying the washer method is to find the uppercase r and lowercase r, or the outer radius and inner radius. And now the easiest way to figure out what the outer radius and inner radius are is to look at the graph and figure out which equation is on top, or which is furthest away from the axis you're revolving about. So in this case, you're revolving around the x-axis, and the equation y equals x plus 2 is furthest from that. So we can say the outer radius is x plus 2, and the inner radius, which is the equation closer to the axis, is x squared. And second step, finding the bounds. Set the equations equal to each other. X squared equals to x plus 2. And so you're figuring out basically where these two equations meet, these points here. And if you can't tell off the graph itself, it's helpful to write the equation and set it equal to each other. So in this case, you get x squared minus x minus 2 equals 0. And we can now split the middle term. So we can do this and take x common out. Oh, actually it's not this. It's x squared plus x minus 2x minus 2 equals 0. And so take x out, x plus 1. Take a negative 2 out, x plus 1 equals 0. And so this factors to be x equals 2 and x equals negative 1. And so these are our bounds. And so the lower bound, which is negative 1, will be on the bottom, and the upper bound, which is the positive value, will be the top, which is 2 in this case. And so after doing all of that, we now know our bounds, we know our uppercase and lowercase r values, and so now we can plug it in. And so the equation is pi times the integral of large R squared minus small r squared dx. And keep in mind, if it's rotating around the y-axis, it would be dy. And these terms should be in terms of y. So it can't be x plus 2, it would need to be y plus 2. Or it can't be x squared, it must be y squared. And so since we're rotating about the x-axis in this case, it can be in terms of x. And so now all we need to do is plug this in. Pi times integral negative 2. R in this case is x plus 2. So x plus 2 square minus lowercase r, which is x squared. And x squared to the power of 2 is x to the power of 4 dx. Right. And so now that you've got all of that, we can now just integrate this. So what I would do first is I would expand this, because we can use the power rule then. So I can say x squared plus 4x plus 4 minus x to the power of 4. And we get this integral sign, pi and dx. And so now, coming over here, we can plug in, or first we can integrate and then we can plug in. So we integrate using the power rule for each of these terms. So I get x cubed over 3 plus 2x squared plus 4x minus x to the power of 5 over 5. And that is evaluated from negative 2 to 2. And don't forget to multiply it by pi at the end. So now all we need to do is input all of these, input 2 and negative 2. And when we input all of this, we can do 2 to the power of 3, which is 8. 8 divided by 3 plus 2 times 2 to the power of 2, which is 4. 2 times 4 is 8 plus 4 times 2 is 8 minus 2 to the power of 5, which is 32 over 5. And we subtract all of this by the lower bound, which is, plug in negative 2, negative 8 over 3 plus 8 minus 8 plus, because negative 2 to the power of 5 is negative 32. And since we're subtracting that, we get plus 32 over 5. And once you subtract this by this and multiply it by pi, that would give us the area or the volume for this solid. And again, the reasoning behind this is that we're taking the outer radius, or large R, which is this bigger cylinder, and we're subtracting it by the smaller r, which is the smaller radius. So in this case, it would be this part. And so when we subtract this large cylinder by this small cylinder, we get what's remaining, which is this part, which is our bowl, or what we're looking for, the volume obtained. And so that's the reasoning behind the washer method. Whenever there's a hollow shape, we use the washer method.